This is Shakil Ahmed. In this tutorial, we will discuss about elastic net regression. Elastic net regression is a method that combines the penalty of lasso as well as the ridge regression. The penalty in lasso regression is called the L1 regularization, and in ridge it is called L2 regularization. So, in Elastic Net, we just add two terms, one with L1 regularization and one with L2 regularization. So it constitute all the properties of the lasso as well as the ridge regression. So uh, what it does basically, the lasso shrinks some coefficients to zero and effectively performs feature selection, while the ridge regression uh, shrinks some coefficients to zero. All the coefficients shrinks toward zero, but the downward, but really rarely sets them exactly to zero in cell, just like lasso regression. So it is good at handling multicollinearity, but not in variable selection. On the other hand, lasso uh, works for variable selection, but not handle the high dimensional issue or the high multicollinearity well. So elastic net regression allows it to perform feature selection as well as and handles highly correlated features. When features are highly correlated, elastic net tends to select all of them together, whereas lasso might pick only one. So in this tutorial, we will show how we can apply the elastic net regression to a data set with in order to predict the average glucose level. And we have again the strokes prediction data with some demographic variables and some clinical characteristics and the average glucose level. We have this column. So I think I have already uploaded data. If not, I need to upload strokes data. You can see stroke data in CSV, and I am just uploading it here. And then we can read the variables, the data set using the pandas library, and then the command is pd dot read underscore CSV, and then the dataset name with extension CSV. And then we can see first 10 observations using df.head command. You can download this data if you want to practice. It is available on Kaggle. You can download it for free and then try this exercise with me. So we need again we need to separate the data into train and test. So we can just we need to import the train test split library and the Elastic Net from the scikit-learn model, linear models, and then from scikit-learn matrix we need mean squared error and R square, as we are dealing with quantitative dependent variable. And then for pre-processing, we need one hot encoder and column transformer. Column transformer basically just works like in R we use lapply or tapply functions to apply all the things on different columns, all the function on the different columns one by one. So the column transform command does it. And the pipeline, basically we need to proceed, or we need to pass all the things through different steps, then we can use a pipeline package. And we also need numpy package. And first we do the data pre-processing. We first remove the irrelevant variables. The average glucose level 2 is an additional variable in the data set, so we are just removing these two variables, and the data name is df model. And then in this data set we have missing values in PMI, so we are just for now we are replacing them with mean of the rest of the column. Basically uh, we have almost 200 observations missing in BMI, so we just find the mean of the rest of the observations and then replace them on the in place of those 200 observations. So DF model, this is the final model, we final data set we are using, and the column is PMI and fill NA. And what you are going to fill, you are going to fill this value, and in place is equal to true. So you can just give this command. If you want to replace with mode, you can write mode here. If you want to replace with median, you can also do that. And then we just extract this set of the data frame with axis. So excluding the response variable, we keep all other variables as the set of predictors. And from the data frame, we extract the average glucose level as the response variable. And now we need to convert the categorical variables into dummies to make them numeric. So one hot encoder command is used for that. So we need to split the columns into two sets. First, categorical features and the numerical features. So we don't need to do anything with numerical features, but we need to convert the categorical features into dummies. So how we can do this? We just create a preprocessor that is a function that will do the preprocessing, and column transformer means it will apply to all columns. So then transformer is equal to we are converting them to number. It will be just in if the transform the value is in number, we will pass through, and the columns on which we are selecting this operation is numerical features, the on this feature this column set. And then categorical, we are converting it into categorical using one hot encoder command, and handle unknown ignore means if unknown there are unknown guesses, we just ignore them. We, for example, we have male, female, and unknown category, then we will only get one dummy for one gender, and the other category will be just get considered as the reference, and the unknown category will also be categorized as the in reference category, and there will be no separate dummy variable for the unknown category. And then categorical feature, we are selecting the columns, this column set, the first column set. Now you can run. I think we have not run this yet. We need to run this one first, and then we can run this, and then we can run this one, and then we can run this one. Now we will create an elastic net model, elastic net, and then this is elastic net. We have already uh, imported this function from sklearn linear models. And then a random state is for to basically while doing uh, random selection, it will start with 4 2, and then create a pipeline that first pre-process the data and then applies the model. Basically we will pass all the data first through pre-processing, and then will apply the model on the data set. So pipeline, the steps, first step is preprocessor. We have already created here what this function does, and then the second is a regressor. So what this function does, this is Elastic Net. We have also created this. So we are using these two functions, and then we will get the results. Now we have just created the model pipeline, but we have not given the inputs. So we first separate the data into test and train with 20% in test set and rest of the 80% into the training set. And then model pipeline dot fit means we are fitting this model pipeline. So it will first pre-process the data, these two uh, inputs, and then we'll apply a model. So then we can predict model pipeline, we can predict dot predict and then x test. So we have x test, x train, y x test, y train, y test. So we are using these values here as inputs, and then we get the predicted values. You can just print y predicted. Now you can see the predicted values of the average glucose level for those who are in test set. And then we can compare these values with the observed average glucose levels. And then we can find the mean square error. Mean square error is the basically the square deviation, sum of square deviation divided by degree of error, degree of freedom. So that is y test minus y predicted whole square, and sum it to all the test sets and then divide it by number of observation in test set, and we find the sum of square of residuals and total sum of square to find the r square, that is 1 minus residual sum of square divided by total sum of square, that is the r square. It is basically the explained variation in the steady variable explained by the predictors. A higher value of r square is always preferred. And then we can print the r mean square error and the r square. Now the next thing is to find the tuned values of the penalty parameters. Here we have two penalty parameters, L1 regularization, one for L1 regularization and second for L2 regularization. We need lambda 1 and lambda 2. And here we have named as alpha and L1 ratio. And you can also call is lambda 1 and lambda 2. So we just created a grid, some grid values for these two, and it is named as parameter grid, and we just created a set of grid. And then grid search cv, this is a function we have imported, we have already imported. If not imported, we need to import that. I think we have imported here, sorry. So then this is the model pipeline. Basically we are using the model pipeline and this thing, and then the data sets, this is already run, we have already run this. And then parameter grid, that is we have created here, and cross validation is equal to 5. It means we are using 5-fold cross validation. And then r2, this is value of the r square, and the number of jobs is equal to -1. It will use all the observations basically. And then grid search dot fit, we just give the values, and then we will get the best values of parameter from all these options. We are running model with all these possible values: 0.1, 0.1, 0.2, 0.5, 0.31, 0.5, 1.5, zero point 0.5, and 2 and zero point 0.9. So we will get all this, and then we will finalize the best score, that is the best R square value, and then we just print them. So you can do this on a separate cell. You can just compare, and then you can run this. So it's working. So the best parameter values are lambda 1 and lambda 2. So lambda 1 is 0.1 and lambda 2 is 0.9. So it is taking this value for lambda 1 and this value for lambda 2. And the R square value is 0.096. This is the largest R square value basically we obtained. So if we keep alpha is 0.5 and L1 ratio is 0.9, then we will get R square of this. Then we can find the best model. This is grid search best estimator. Basically, we have already run an estimator. You can see here is the estimation stage and the model pipeline. So from the model pipeline, sorry, I think I just missed the command. So best grid search and best estimator means we are using the best estimated values. Uh, we are using basically the estimator with best lambda 1 and lambda 2, and then best model. This is the best model, and then predict x test. We are just predicting x test value, and then we will find the MSE tuned and R square tuned and print them. So now these values are 1773. You can just compare it with this. Now the MSE is much reduced and R square is increased. Now R square is 0.07. Here R square was 0.058. So this is now the tuned value for the test set. Basically, we tuned the parameter values for the trained data, and now we are fitting this for test set. So it's also performing well for the prediction in the test set, as we did cross valid five-fold cross validation. So for the training data, we get the parameter lambda 1 and lambda 2 values, and then for these values we run the regression line again, and we predict the test values of the y, and we get the MSC and mean square error that are much improved from the previous ones. And then we again uh, complete the steps: trend, regressor, and model pipeline, and named steps means we are only doing the regression step. Now get the feature names. After the one hot encoding, the processor step has a list of transformers, and the category transformers one hot encoding has get feature names out methods. So feature names means a list of columns in numerical features plus a list of uh, columns in processor name transforms. Basically, we have just transformed the categorical variables and we keep the numerical features as it is, and then get feature names out. We are just extracting the feature names, the name of the columns. So this is feature names set. We have a set with only feature names. Can just copy it and run it separately. Successfully run, and you can print feature names. So these are the feature names we are using. Now we will see the feature importance based on the coefficients. The feature will be given the highest importance if the uh, coefficient is high. For example, coefficient, trend, regressor, and then coefficient. So from trend regressor, we are just extracting the coefficients, and feature names, PD series, we are just writing a series with coefficients and their index. So we can just see, and then sorted feature importance, this is the feature importance, and sort values ascending. So it ascending is equal to false, it means we are just writing the values in descending order. So hypertension has highest impact on average glucose level, and the gender has least importance on least effect on the uh, average glucose level, and these variables have no effect on the average glucose level. This is because of the uh, value of lambda we choose that shrinks that shrink the coefficients of these variables to 0. So we can also display it through a feature importance plot, or you can just import matplot library as PLT and Seaborn as SNS, and then you can uh, plot the sorted features importance. These are sorted important features on x-axis and their names on y-axis. Index that are called index, and then the title, and this x label, and this is y. So this is all about elastic net regression model that is used for penalizing the uh, L1 regularization term and L2 regularization term at the same time in model, to handle with the high correlated variables, as well as for model selection. It also selects the most important variables. So we can see these variables are most important, and in some cases you can just ignore the other variables which has no important, and you can do your analysis with the important variables. So if I hope you have uh, got enough information about elastic net regression. If you need any clarity, you can always write in comment section. Thank you.